Everyone says the same thing right now. AI will replace software engineers. But I think that statement is a bit misleading. Not because AI is not powerful, it most definitely is, but because we are confusing two different things when it comes to software engineering. The first problem is building the thing, and the second problem is identifying what to build and why. And AI is only good at one of those. Let's break that down. And if you're a software engineer who is worrying about how AI will affect your career, this channel focuses on breaking down those core skills that will make engineers super valuable even in the future. So if that kind of stuff interests you, consider subscribing for more videos like this. With that out of the way, let's get straight into it. In today's video, I'm going to talk about a couple of different things. Number one, what is AI actually replacing? Number two, which engineers are most at risk? Number three, and what will be those core valuable skills that will make engineers even valuable in the future? Because saying that AI will replace engineers is a bit misleading, but AI will most definitely replace a certain type of engineer, which we'll be talking about in today's video and how to get those core skills, which will make you even more valuable going forward. At the beginning of the video, I mentioned there's two types of problems in software engineering. Number one problem is building the thing, and number two is knowing what to build and why. So let's first start talking about problem number one, building the thing. So this entails what AI is already good at, given extremely specific instructions and executing on it. It's very mechanical, it's very technical, and AI already does a very good job at it. You must be seeing this at your job as well. I mean, I know you use Cursor. Nowadays, you must be offloading most of your coding work to AI. You must be seeing how good it is at these specific things. So for example, if I tell an AI, hey, build me an API which takes ABC input, spits out XYZ output, let's say user data, and queries this another XYZ database schema in this particular way to fetch this information to return in the API. You'll see it can do a very good job at it. The same thing applies to other areas as well, where it could be writing code documentation for you, it could be generating unit tests for you, it could be generating more CRUD endpoints for you, even generating apps from scratch. But there are some interesting thing that goes on there where an engineer might have to interfere, but AI will definitely get good at this in the future. So what I'm trying to say is if the instructions are extremely clear and unambiguous, AI will definitely perform well and will continue just improving over time. When it comes to software engineering, this is what most engineers are worried about because most engineers think that, wait, isn't this my job? Wait, am I not supposed to write CRUD endpoints? Wait, am I not supposed to create these APIs and all of that stuff? Well, my friend, that is just one part of software engineering. And I've made a whole other video about what the difference is between software engineering and programming. I'll link it somewhere up there where you can go and take a look and actually understand what the actual difference is. But yeah, here's the catch. Coding was never the hardest part about software engineering. That's actually the easy part. Now, this brings me to point number two or problem number two, knowing what to build and why. So the real challenge in software engineering has always been something else, deciding what to build and why should the systems behave like they do. So to be honest, business requirements rarely ever appear as clear, unambiguous instructions. 100% of the time, they are going to be extremely ambiguous, and it's our job to break them down into clear instructions, which in the past, which were given to junior and intermediate developers to do, now it's being given to AI to execute on. Let's take this example. Let's say there's a business requirement saying we should allow users to delete their account. Most junior or intermediate engineers are like, okay, I'll implement that ASAP. But proper senior plus engineers take a step back, they'll start asking questions. So do we delete the data immediately, or can that be scheduled for deletion in, let's say, 30 days? Also, if we delete the primary user data, are we also required to delete the secondary user data? What about any logs or something that might have any specific user required information in them? What happens if a user deletes their account when, let's say, a payment is processing or something like that? As you can see, there's a heck of a lot of questions that can come through or like come forward when you think about a business use case. It's not clear, it's not specific, it's extremely ambiguous. But most engineers, they tend to approach this the wrong way. And so when they think about a problem, they think of it just in terms of coding or, okay, I'll design the API this way. But that's, like I said, that's the easy part. Knowing what to build and why and how it should perform, that's the difficult part, which needs engineers to develop these skills, which are not usually taught. So yeah, a quote unquote simple features can have a lot of hidden trade-offs underneath. It's the engineer's job to identify these trade-offs, surface them to the relevant stakeholders, and identify what sort of risks they are fine with before we pitch or propose a solution to the problem instead of just jumping heads down and coding out some implementation, which might lead to the feature not performing the way it is and leading to surprises and miscommunication down the line. Going back to trade-offs, as you can see, there can be multiple different trade-offs, even for a simple problem as letting users deleting their account. There's compliance, there's performance, there's consistency, there's availability, simplicity, stuff like that, right? You have to see which sort of trade-offs are more fine with the stakeholders, because we might think, shit, I think we should keep the solution simple, but what if they want something else altogether which will bring the business more reward that way? So it's your job to uncover that. AI is not going to be doing that. Understanding business context, anticipating future states, and making the relevant judgment calls is where true engineers shine out from all these other engineers who only ever focus on coding or executing these things. Now that we have taken a look at both the problems, let's take a look at what the real risk is. I was actually going through the Stack Overflow developers survey for 2025 and something interesting popped out. It said that 64% of the developers say that AI won't replace their jobs. More than half of them don't even use AI regularly in their day-to-day jobs. And around 40% or so will said that they won't ever even adopt AI in their day-to-day jobs. That gap, my friend, is extremely dangerous because I can guarantee you AI will most definitely replace a certain type of developer job. The developer who thinks their job is just to code out Jira tickets, my friend, it's time to pull up your socks. You're most definitely going to get replaced. So if you think swinging the hammer is what you're good at, my friend, AI will automate swinging that hammer for you. And to be honest, the value of that skill is dropping significantly fast. So now this brings me to the next section about which type of engineers won't be replaced by AI, at least not anytime soon. So if you took the time to watch the video I had made on software engineering versus programming, you will sort of know what I'm going to allude to here, where software engineering is not just coding. Yes, coding is a big part of software engineering, but that's the easy part of it. And when we talked about the stuff in problem 2, the engineers who truly focus on that are the ones not going to be replaced anytime soon by AI, if not at all. So there's 3 main things that I can think of when it comes to these sorts of engineers. Number 1, problem finding. Number 2, communication. And number 3 is taking the right judgment based on how you propose your solution. So number 1, problem finding. A lot of engineers, we wait for instructions to be given to us by, let's say, PMs or business or whatever, but these proactive engineers, they find the problem themselves. It could be business problems. It could be problems where people are struggling in their team and how they automate using AI, for example, to make life easier for them or to make life easier for the business. So finding problems, very important skill. Number 2, communicating those problems or even communicating solutions to those problems. So like I said, an engineer's job is not just to implement something. It has to be understanding the risks, the various ways to implement a particular solution, and surfacing those trade-offs in a meaningful way that will help them get the buy-in from various stakeholders and whatnot, so that they know, okay, if I, let's say, implement option 2, that will provide a lot more business value than something like option 3, which might be more optimal, but doesn't give as much ROI. So it also involves sitting with a lot of these various stakeholders, could be PMs, could be leadership, to understand what they really need in asking questions, which can be sometimes be hard to ask, but those are absolutely required. And so to give you an example is what we talked about in the problem 2 part of this video, where we need to give permission for users to delete their accounts. Asking those relevant questions to understand what might be the best way forward is what I'm talking about here. So AI cannot read the room. It has to be given those very specific and unambiguous instructions for it to perform in a particular way. When it comes to human interaction, to truly understand the business risks, ROI, and stuff like that, that's when you understand what's the best solution for this, and that's what you instruct the AI to execute for you. But all the stuff that preloads, even the implementation part, that's the difficult part that most engineers struggle at and are never taught. And also now going to point 3 about using your own judgment. So doing the relevant trade-off analysis is fine. You can evaluate 3-4 different options, but knowing which option will be the most beneficial for the team or the company is the very crucial part. Because sure, you can surface the trade-offs, but knowing, okay, these are the trade-offs, and based on our historical risk and ROI and everything we have done before, this is, I feel, would give that particular risk-reward ratio that the company will be fine with. Knowing that point of view will also help you impress leadership and all these other stakeholders. Because at the end of the day, you're not just someone who implements, you're someone who understands what you implement and how it will benefit the company in whatever XYZ way. So all of these skills, if you see, that still requires human intuition and human interaction. The other stuff, the technical and the mechanical stuff, shit, man, that's easy. That's what AI is already doing, and that's what most engineers are afraid of. But if you're this specific engineer or the respected or the authoritative engineer who focuses on problem finding, communication, trust building, and doing the right judgment, my friend, you'll be so valuable. At the end of the day, you can be that engineer who does all of this and has AI execute for you. When now you might have juniors or intermediate people under you. So if you are a junior intermediate engineer and you want to know how to stand out, this is it. This is literally it. Focus more on your human skills. Seems counterintuitive, but you'll be surprised at what this will do for you. So anyway, that was a bit of a rant from my side. So when it comes to will AI replace software engineers? Yes, it will most definitely replace certain types of software engineers. The other people who are doing all these different things that we talked about will continue remaining valuable and whose value will actually increase over time, because leadership will always need those engineers who understand business risk and can implement stuff accordingly, which AI can definitely help implement. So they will be the glue between business and the engineering side of things. So the core skill of engineering, which is to take ambiguous business problems and to convert them into unambiguous, clear instructions, that skill is still going to be extremely, extremely valuable and will continue being so going forward. So leverage that going forward. If you suck at it, take time to develop it. And if you are extremely intentional about building these sets of skills so that you can stand out and continue being valuable over time, book a chat with me using the link in the description below. We'll see how it is working together and how we can help you. And with that being said, as always, I'm just here to help.